Time travel. Between science fiction and real science, time travel has long captivated humanity, straddling the line between fantastical storytelling and serious scientific inquiry. While it remains a staple of science fiction, modern physics teases the possibility that certain forms of time travel might not be entirely impossible, at least in theory. Let's explore where science ends and imagination begins. The science of time travel, one Einstein's relativity, time dilation. Einstein's theories of relativity revolutionized our understanding of time. According to his equations, time slows at high speeds. If you travel near the speed of light, time passes slower for you than for someone at rest. This is called time dilation. Astronauts on the ISS experience this marginally, aging a fraction of a second less than people on Earth. Gravity bends time. Near massive objects like black holes, time stretches. In Interstellar, the cruise hours on a water planet near a black hole equate to decades on Earth. This trip to the future is theoretically sound, but requires extreme conditions. While relativity permits forward time travel, returning to the past remains unproven and controversial. 2. Wormholes. Cosmic shortcuts. Theoretical bridges in space-time, called wormholes, could connect distant times and places. However, keeping them stable would require exotic matter with negative energy, a substance we've yet to discover. Even if possible, wormholes might collapse instantly or be microscopic, making them impractical for human travel. 3. Quantum mechanics and parallel universes. Some interpretations of quantum physics suggest every decision spawns a new universe. If true, time travel might involve hopping between parallel timelines. While this avoids paradoxes, e.g., killing your grandfather in another universe, it's purely speculative and lacks experimental support. The paradox problem. Time travel to the past introduces logical nightmares. The grandfather paradox. If you prevent your grandparents from meeting, how could you exist to time travel in the first place? The bootstrap paradox. What if you give Shakespeare his own plays? Who truly wrote them? Physicists like Stephen Hawking argued such paradoxes make backward time travel impossible. Chronology protection conjecture. Others propose workarounds. Self-consistency, Novikov principle. The universe corrects itself. Any action in the past already happened, so paradoxes are impossible. Multiverse theory. Changing the past creates a new timeline, leaving the original intact. Time travel in pop culture. Science fiction uses time travel to explore existential themes. Destiny versus free will. Back to the Future shows how altering the past risks erasing the future, while Doctor Who often grapples with fixed points in time. Ethical dilemmas. In Looper, assassins confront their older selves, questioning identity and morality. Hard sci-fi. Films like Primer dive into the technical complexities, depicting time loops and causality with brutal realism. Yet fiction often bends rules for drama. Real science demands consistency with physics. No DeLoreans or flux capacitors allowed. Will we ever time travel? To the future, already possible. Astronauts technically time travel a tiny fraction of a second. With advanced technology, e.g., near light speed ships, we could leap centuries ahead. To the past. Most physicists deem it impossible. Even if wormholes or closed time-like curves, CTC, exist, they'd require unimaginable energy and might destabilize space-time itself. Current research focuses on understanding quantum gravity via string theory or loop quantum gravity in probing space-time's fabric. Experiments with entangled particles or time crystals hint at weird temporal properties, but none enable literal time travel. Why does it matter? Time travel isn't just about machines or paradoxes. It reflects human curiosity and our desire to control fate. It asks, are we bound by our past, or can we reinvent ourselves? What does it mean to exist in a universe where time is fluid? Even if time travel stays fictional, it inspires scientific breakthroughs. GPS satellites must account for relativity's time warps to function accurately. Meanwhile, pondering time's nature pushes us closer to a theory of everything. Conclusion. Time travel lives at the intersection of ambition and limitation. Science offers a sliver of hope for visiting the future, but the past remains locked away, protected by paradoxes in physics. Yet in a way, we all time travel, forward at 1 second per second, shaped by memories of the past and dreams of what's ahead. As Einstein said, the distinction between past, present, and future is only a stubbornly persistent illusion. Whether illusion or not, time's mystery continues to drive both science and story,